Hi, Ovie, how you doing? Not going to be human. It's like when you are here. How are you?
I'm good, man. Anyhow, how you doing?
I'm fine. Okay. Sorry, is that speaker here already?
Yes, I am here.
All right. So, not to waste our time, everybody are welcome to. Let me technically the first train webinar. Yeah. So you are welcome, and this is actually facilitated by Bunzz. So the main thing here is to help you, us, everybody understand real world use cases and training, all that it takes. So there's a lot to learn today and there's a lot to digest as well. So dApps, smart contract deployment and all of that. So I hope we all have our pen, journals to get it all done. So be ready to ask your questions and be ready to learn. So we are good to go. So I don't know. Everybody knows me, right? So I don't need to introduce myself. My name is Daniela Messe. So over to you as speaker. Introduce yourself and let's kickstart this.
All right. Good evening, everyone. We
Good
share my
evening.
screen shortly, so I can. I'm certain that everyone can see my screen. Is that correct?
Yes, yeah.
Okay. Just hold on. All right. Good evening, everyone. My name is. A hand is raised. Not sure that is okay. That's fine. My name is Trust.
Okay, Timlane, do you have a question?
Yes, good evening. Good evening,
Okay,
everyone.
good evening.
I think this session is not being recorded, and I want to ask if you can help us record so that we can fall back to it.
All right,
It is
thanks.
recorded. Thank you very much for that. It's already recorded. The recording starts immediately. Eniola introduce herself. Yeah, so be rest assured that after this whole call to be uploaded and made available for everyone, and also including the slide if anyone is interested to.
Yeah,
Thank you
thank
very
you.
much. Amazing.
You're welcome. All right. Sorry for that.
Yeah, it's fine. It's all right. So once again, good evening, everyone. You're welcome to today's workshop. I'm aware that this is like the second or the third workshop so far in the program, and I'm excited to be with everyone today. My name is Trust Onyekore. I'm a blockchain architect. I currently work with the DevRel team at Bunzz, educating and supporting blockchain developers to make dApp development easier and, of course, to improve the way blockchain developers build dApps. And today we're going to be looking at the understanding how blockchain applications are built from a high level architecture down to a low level, and probably look at what are different use cases and how building Web2 application is no different or somehow compared to how we build a Web3 part of those kind of applications. And then we'll go into a quick demo on how Bunzz can simplify and, of course, improve the process of building dApps. And as you go on in towards the rest of the program, you definitely get to understand most of the things being discussed now. So, disclaimer, everything to be discussed today may not make sense at first. That's fine. But try for it to make sense. But if it doesn't make sense, that's okay. You can go back to recording. And of course, as you proceed in your classes going forward, it will definitely begin to make sense. Web 2 is Web 3. Web 3 is, okay, a little bit of another, not really disclaimer, but like we are going to be using dApps and Web3 apps interchangeably. They all mean the same thing. So I can say dApp, Web3 dApps, they're all the same. Web3 applications, of course, are decentralized, and dApps, of course, means decentralized applications. So they mean the same thing. I prefer using dApps, but any of them can work. So in case I say Web3 app, it still means the same thing as I'm trying to explain. Web3 is Web 2, but Web 2 is not Web 3. I was preparing for a conference some time ago, and I was asked to send in a topic for the talk. And this was what came to my mind 9 minutes. And it made sense to me at the time to say that Web 3 is Web 2, Web 2 is not Web 3. Does it make sense to anybody on this call? Can you tell me what this means to you? When you
Yes.
see this on screen. Yeah, who's that?
Ovie.
Oh yeah, go ahead.
So when you say, like, what I got from this is the fundamentals of Web 2 is what you use in building Web 3. But the same can be said for Web 3. I don't know if you get what I mean.
Yeah, definitely got it. Thank you. Anyone else will have a different opinion on what you understand for what's on the screen? Yes, Toyosi.
Okay, good evening. I would say that Web 2 is not decentralized, or like, it's not decentralized, but Web 3 is built on Web 2, so to speak.
Thank you very much. They're all fantastic points. And yes, that was exactly what came to my head when I made out that particular topic for the talk. You can find elements of Web 2 in Web 3, but you can't find elements of Web 3 in Web 2. That was what came to my head. And of course, what you've just said validates that I was making sense. And of course, it's making sense. We're going to see what it actually means in architectural structure of how a Web 2 app is built, the difference, and compare that to how a Web 3 app is built. And then we'll now look at how we can bring all of those things to life and ease development of these applications. To understand what the sentence, hold on, let me mute notifications, sorry. To understand clearer what this sentence means, let's take it back. Let's take some step back to Web 1.0. I'm sure you guys already know most of these things. I won't really do much on this. Web 1.0, 90s, 2004 was basically read only. We had to just consume data that was given to us on the internet. We couldn't contribute to this data. And then Web 2 improved contributions. We could see, contribute, interact with data that we could see on the internet. And that was where most of these giants, Facebook and the rest of them, really monetize data that was being contributed. So I can post pictures, I can comment on the pictures. They have thousands and millions of pictures and text conversations. They can use some profit data based on our contributions. And that was where issues came about privacy and not being able to monetize your content and so many other things that came around Web 2.0. And that was exactly what was trying to be solved by bringing in Web 3, so that we can not just contribute, we can also read and also own our data and monetize our data. So you can find elements in Web 2.0, which is the read and the contribution, which is the write, in Web 3. But you can't find ownership as you can find it in Web 3 in Web 2. So that is what this means. Web3 is Web2, or Web2 is not Web3. Another way to look at this is also to validate for those who are coming from a Web2 background, to validate that you don't need to drop all you already knew about Web2 development to begin Web3. We see that for most cases where those that want to come into Web3 are beginning to say, they talk as if when you enter Web3, you're leaving everything Web2. And Web2 is the fundamentals. It's more like an upgrade. We can see that in Web3. So you are definitely going to rely heavily on your existing skill sets in Web2 to actually scale faster and build more usable dApps applications in Web3. What makes up a dApp? How do we build a dApp? What are the components that make up a dApp? We're going to break this down using a real life application called Medium. How many of us are familiar with Medium? I'm guessing most of us, right? Medium. Yeah, thank you. Thumbs up. Yeah, fantastic. Yeah, so Medium. Medium is a blog. Is a blog platform. I mean, back then, tech, for those in tech, Medium, that was like, the go-to place to write articles and all. But then Hashnote came, and then it seemed like Hashnote seemed to be taking all the shine. So Medium allow people to write articles across different industries: personal development, religion, career, business, startup, development, engineering, architecture, whatever. There's a whole lot written on there. Web Medium is definitely Web2 application. We're going to look at it from two sides. Medium, we're going to like more like a mini product tear down. For those who product managers have product tear down, they take a product and they tear it different pieces. We're going to do a mini tear down, basically technical part of it. We'll take the current medium, which is Web2, how its architecture of that basic architecture of medium, and then we'll compare it to a proposed version of the Web3 part of medium, the difference, or we can learn from the difference, and how smart contracts play a vital role in building dApps. So the first, and if you may not know Medium, of course, if you have built a blog before, then it's easier to, relate to what we're about to discuss about Medium. So like I said, Medium is a blog article. You write articles, people comment. Is that a hand being raised? Okay. People comment. Or you can share your articles, people clap for you, and so many other those things here. So the first thing that Medium has to build Medium in a Web2 part is that there must be a place to store data, such as users, posts, their tags, their comments, their likes. Store all of those things, followers, number of followers. We need to store data. That's the first thing that has to be in place for Web2 version of Medium. That's what currently Medium actually has. The second is a backend that defines the business logic. And that is where the Python comes in, or you use Python for Django or Flask, or you use Node.js or Java or Go. That is where the backend comes in to define the business logic. What happens when I publish a new article? What happens when someone claps for me? Medium has a partner program where they pay authors monthly. They pay authors monthly based on those that read the articles. So when you read, they pay via Stripe. You come for checkout, payout. Business logic, of course, is being defined and executed by well-structured backend code. So you need a backend that you use to define and bring the business logic of Medium to life. And lastly, as a front end, and defines the UI logic of Medium. I need to see, of course, you need to read the articles. You need to see who wrote it, the profile picture. You need to see your monthly payout or the earnings for month, the dashboard. You define the business logic. These three things. Is that a hand? Okay, hold on.
Yeah.
Yeah, just hold on. I'll call you very, very shortly. So these three things are what makes up Medium. The first, store data. We need a back end to define the logic, a front end to bring the back end to life, and three basic things that make up Medium in the Web3 parts of things. And this is how the basic architecture looks like. The front end, HTML, CSS, JavaScript, the back end, any of those Python, Django, Go, last database store, and all of them is being served in a web server that can call it in the browser over the internet. Basic architecture for how Medium works in the Web2 space. Yes, you can go ahead with your question.
So my question came about from the last slide, the slide before this. So I wanted to ask where, um, yeah, where like don't the first and second, like don't they do the same thing? Yeah,
The
man.
first and second.
Yeah, it's like it's not backend code that powers server side of things and everything.
Yeah, it does. It does, no doubt. But it has to be when we're trying to break down the architecture, storage actually stand alone because as a whole lot happens in storage. They all link together, but storage on its own is standalone. As we can see, or you can see, definitely saw on database. Of course, as a back end where the business logic, the code is written, but it has to be connected to database to store those data gotten from those interactions on the back end. They're connected, but they're most likely almost all the time separated because storage has database has its own different what's the word now components that make that up. They're connected, but most likely always being separated for architectural purposes. Does that make sense to you?
Yeah, it does.
All right. So that is basically how, if you want to build a blog or a medium, that's how it's definitely going to be for a basic architecture for that. Now let's now compare how this will look for a Web3 version, a DAB that does what Medium does. A Medium wants to move from Web2 to Web3. How will that work? And how can we, if we want to build ours, look at it, and then we can compare, and contrast, and then find lessons from there, and then proceed to take lessons and how that will work as we proceed. The first is that the front end, as we see, front end is this thing for the Web2 part, remains the same. We need a front end for the Web2 version of Medium. And that would also mean your HTML, CSS, React, whatever framework remains basically the same. There are some exceptions, but most of 90% or 99% of the time is always the same front end that we use. But then the second part is where things begin to change. The server. There is no centralized web server where the back end logic resides. We'll see why that is the case. The front end is the same, but then the back end begins to change in the web server area because we are no longer hosting the whole application, not really hosting. The business logic no longer resides in the centralized web server, but this time around in a decentralized web server. We'll see how that works when we go to diagram architecture of that. And the biggest difference is smart contracts. Smart contracts are written to define the logic of the medium application we want to write in a Web3 space, deployed to a state machine on a decentralized network. Basically the same as the second one, but smart contracts are not visible. They're not being seen. It's not existing for the Web2 parts of Medium. But when you want to build for that of the Web3, it has to exist. So you can look at a diagram, and you can remember how the previous diagram looked like. There's a difference. In the Web2 version, we had the front end backend database in a web server. Now, this time around, we have the front end. The back end, things begin to look differently. As a smart contract, there's an EVM, there's blocks, and then we have which all make up Ethereum blockchain. This diagram means so many things, but we're not going into the meaning of all of them, but we're going to the meaning of how this affects our media application we want to build. There is a front end. We did see there was a front end in the Web2 version of Medium. In the Web3 version of Medium, there's still a front end. But now, front end, of course, where we're definitely going to see what is being written, we interact with it, we follow, we write, we do all those things in the front end. The business logic, Medium has a partner program that pays people money at the end of the month. You can publish an article, you can share the article, you can clap, you can do all of those things. Now, instead of having this business logic written by Java or Django or whatever other language, we now use smart contracts to put in the business logic that are being run executed by the EVM, that are being stored, transactions being executed are stored in different blocks of chains in the Ethereum blockchain. EVMs are very important parts of the whole back-end system. How many of us are familiar with JVMs? JVMs, or a Java virtual machine, as JVMs, right? And what JVMs do, of course, we know that the computer does not speak human language. And most of the Java, the Python are all high-level languages. And we write them in our IDEs, we write them, but of course, they are being broken down into bytecodes that are executed in JVM case by the Java virtual machine. The same case happens here also. The smart contracts right in Solidity are being deployed, but of course is broken down into bytecode executed by the Ethereum virtual machine. And transactions that have been executed, the codes, the storage, everything is being stored in blocks, in chain, blocks of chains of block. Which one? Chains of block, blocks of chains, and the chains of blocks here are blocks of chains. Chains of blocks is better. I think that's a better word. Chains of block here that have been, of course, in the Ethereum blockchain. This is how a basic Web3 version of Medium looks like. There is more, we'll look at that more, but this is the basic comparison. A Web2 application has a front end. Web3 application has a front end. But the back end is where the most differences occur between Web3 application and Web2 application. Smart contracts begin to show. The EVMs begin to execute the smart contracts. Storage being executed are being stored. Transactions are being stored on the block. They're overall in Ethereum blockchain as a whole. This is how it looks like. But now the question will now be, if you look at this diagram, it is separated. There's a red separating both the front end and the back end. How do we connect them together? In other words, how does the front end code communicate with the smart contracts on Ethereum? Usually, if it's Web 2 or use APIs, connect APIs, then that fits and that makes sense. Is it the same thing for the back end parts of a DAB? This is a clearer architecture of how that will work. So we'll take a look at this one after the other. Will you understand that, of course, there is a front end, you understand there's a back end with smart contracts, EVM, and then the blocks are all stored. You understand those two parts. But there are new items on this architecture, and there is the signer, there's providers, and then there is IPFS. That, again, there's JSON RPC. That's like the new things both here. So let's take a look at them one after the other. Sorry, hold on. If there are questions on the chat, I can't see them now. I'll probably go back in intervals to check questions on the chat. But if it's very urgent, I can't wait. You can raise your hand. The beep will definitely bring me back to the Google Meet interface. To interact, okay, has a hand raised already. Okay.
Okay, please, can you zoom in a bit?
Can I zoom in a bit? Can I see? Okay.
Yeah. Thank you.
Can I zoom in a bit? Let me see. Okay, I don't think I can, but just hold on. Is there another question? Yeah, go ahead.
You can actually zoom from your phone or your device. If you are using your phone, you just touch where you are sharing. The screen is being shared and try to zoom it with your hand, like enhancing it. I think that is the best way.
Yeah, I'm not using my phone. I'm on my laptop.
The guy that asked the question.
Oh, question. Who's that?
I mean, the guy that asked the previous question for you to zoom your own.
Okay,
So I'm
okay.
answering to him. He can actually zoom it with his own device by touching your share screen and if he's using his mobile device and try to enhance it, I think that will make the picture enlarge in his own image.
All right, that's fine. Thank you. I can't do anything more from here. So yeah, that'd probably be a better option, right? But if you're using a laptop, I think there's no issues with those on a laptop because it has to be clear over there. Yeah. So going to the question, of course, is how do we interact with front end code on how does the front end code communicate with the smart contract on the back end code? And so to interact and connect data and states of the blockchain to our front end, we need a node server that can take that data and transmit going forward, the read and the write. We need a node server, usually called the provider, that updates data on the front end and of course send back data, a provider. There are two options here to broadcast new transactions. Two options. Either you build your own node server that runs on Ethereum blockchain, or you use third-party services like Ethereum, Alchemy, and QuickNode. Building your own node server is painful, and of course, if you may not really have the enough what's called bandwidth and storage for a typical laptop can handle, and so it can be quite issues come about for scalability and all those problems. So the best option is to use third-party providers that are taking the hit on the back end. So you can leverage leverage them to the APIs to interact with your Ethereum block back end to your front end. Providers such as Ethereum, QuickNode, Alchemy, MetaMask 2 is a provider, but not everybody actually knows or use that. Mostly it's Alchemy, Ethereum, and QuickNode. That's for the providers. Now, remember, you were trying to build a medium. Medium, you publish articles, and people see articles. To read on the blockchain, you don't need to sign transactions. You don't need to pay gas fees to read. But to write on the blockchain, you need to sign transactions. To update the states of a blockchain, you need to sign transactions and pay gas fees. Okay. All right. I don't know if this is. Can the question wait? If yes, no, but go ahead.
Good evening. Can you please come again about providers and node servers? I didn't get that part so well. Thank you.
All right. That's fine. Okay. Yeah. So we have our front end, and we have the smart contract on the back end executing AVMs and the blockchain. So how do we put them back? How would interact both of them together? That was where node servers come in. And the node servers that are responsible for doing that are called providers. There are two ways to set up a node server. Either you build your own node servers, which can be hectic and of course stressful, headache of running the node yourself, can take days to set up your own Ethereum chain. And of course, there's bandwidth issues, storage issues, scalability, maintenance. That can be a lot. Second option, which is actually the best option for your use case, is to use third-party services who are taking the heat of the servers themselves. Just leverage your APIs to do your interaction from Ethereum backend to your front end. Providers who are the third-party service providers, examples are Alchemy, Ethereum, and QuickNode, as you can see on the screen. MetaMask, but usually MetaMask is not very popular, but it can also be a provider. But Alchemy, Ethereum, and QuickNode are most popular being providers. So you can leverage out APIs to interact to connect your back end to your front end through JSON RPC, and that can make sense. Is that clear enough? So as I said, yeah, it may not make sense now, but when you go back further into your classes, when you begin to build smart contracts, interact smart contracts, there'll be a second workshop for Bunzz, and then by then you must have already understood how this works in practical. This is theory in the architecture, but once you build your smart contracts yourself, you're interacting, it begins to make sense, a clearer sense. But understand this from a high level point of view, that this is how it works to connect your back end Ethereum backend to your front end, you need a node server provider, which can be used through Alchemy, QuickNode, or Infura through APIs like JSON RPC to your front end. So since we are trying to architect Medium, as you can see on the screen, I was trying to say that Medium is publishing articles and reading articles. I come to Medium, I see articles. Idris could write articles about DevRel and Web3. I can read it. I can go and see other people's articles. But once I want to publish my own article, to read on the blockchain, you don't need to sign transaction or pay gas fees to read. But once you want to write, once you want to update the state of a blockchain, you have to sign and pay transactions. That is where MetaMask comes in. I have a new article to write. I'm done. I click publish. My MetaMask pops up to sign the transaction with a little gas fee. I do, and the article is being stored in the database, which is being called on by a provider, being queried by the front end, and it shows on the browser. Does that make sense? I think I've actually skipped a lot yet. I think when signer. Yeah, so signers, MetaMask is for signing transactions. And so to post articles on Medium, we need to sign transaction and pay gas fees. That's when MetaMask comes in. But to read, you don't need to sign transactions. But to write, you just sign transactions. So I publish a new article on Medium. I put my profile, my pictures. I put whatever I need to put. I click publish. MetaMask pops up. I sign it, and I put it on. I sign it here. I take gas fees, and then it's back to the database. And it's being created on the front end, and it shows there, and it's stored on the blockchain. Any questions so far? All right. So, I mean, most of us.
Okay, someone is asking me. Okay, someone is asking the chat. Let me read the question. So this person is asking if there's a lot of questions here. If MetaMask is both a signer and a provider. And someone is also asking if Infura and MetaMask is the same thing. Do you get that?
Yeah. I got that. So I got that. So the first. Yes, I do. I definitely get that. Yes, I do. I definitely get that. Infura is not the same as MetaMask, of course. As a reason, let me read that chat again. And they said most people at source and notes Infura is owned by Consensia, which owns MetaMask. No, it's not the same. I mean, they have different use cases. The fact that it's owned by the same people doesn't make it the same. So it's not the same thing. That's the answer. Going into technologies may be confused, but the answer is no, it's not the same thing. For Kenny is MetaMask is both signer. Yeah, it's both signer and a provider. Now, MetaMask is a tool that makes it easy for applications to handle key management and transaction signing. MetaMask stores the user's private keys in the browser. And whenever the front end needs the user to sign transactions, like I mentioned, publishing a post, it calls on MetaMask. MetaMask also provides a connection to the blockchain as a provider in quotes. Since it already has a connection to the nodes provided by Infura, it now needs to sign transactions. So in that logic explanation, MetaMask is both a provider and a signer. Signer because before you update on the blockchain, you have to sign transactions. It calls upon MetaMask. Provider because it provides the connection to the blockchain because it already has a connection with the nodes being provided by Infura since it needs to sign transactions. I don't know if there's any simpler way to describe this, but the answer is yes. It is both a provider and a signer. Try to make it make sense. If it doesn't make sense, I'll go again somehow. I don't know if I can use basic terms. But if it doesn't make sense, a more practical approach would definitely make sense to you. Blockchain development, software engineering, theory can be confusing. Once you go into practical sense of it, it begins to make sense. But understand that yes, MetaMask is both a provider and a signer. what I've just said. I know I spoke too many grammar. I don't know if that's clear. Is that clear, Kenny?
Yeah. I think I get it.
Oh, okay. Yeah.
So it simply means that MetaMask can perform two operations then,
Yeah,
because like
correct.
I know the fact that MetaMask is like a browser thingy that you install to get access to your what do you call it, blockchain accounts. Yeah,
Mm-hmm.
like a few demo, and I can access my accounts through MetaMask. Yeah, so that is the part I know about MetaMask. But being a provider is a little sketchy for me. But I think I get the fact now that it is both a signer and a provider to access the Ethereum blockchain. Thank you very much.
All right, great. Yeah, great, Kenny. Yeah, thanks. Okay, let's proceed. Now, IPFS Swarm, that's the storage parts of this. So we have the front end, the back end provider, we sign transactions, the storage, and the blockchain. This architecture, as you see, that has IPFS Swarm, it makes sense, especially because we're building an app where all the smart contracts and data live solely on the Ethereum blockchain. If anyone who has built an app on the blockchain before, you know that storing everything on the blockchain can get really expensive, really fast, because it just gets expensive really fast. Yes, it does. So why does it get expensive really fast? With Ethereum, the user pays every time they add new data to the blockchain. That is because adding new data to the blockchain increases the cost of the nodes that are maintaining the state machines. So you have miners who approve transactions. Proof of stake as basically who has the highest stake gets to be the one to get the reward and approve transactions. It happens every single time. They need gas fees to run those things. And so if we keep storing data, transactions, it can get expensive real fast because these miners or the signer, they call them validators of the nodes, need to get gas fees to make this transaction happen. And can get really, what's the word now? It can get expensive really fast. Now that is where hybrid dApps come into play. We have 100% full-scale dApps. These are dApps that from top to bottom, they are decentralized. But there are hybrid dApps that are partly centralized and partly decentralized. An example would be if we are done with our Medium application now, and we host the application on AWS, on GCP, on Google Hosts. I'm just saying, I'm not sure that will fly, but I'm just saying Google Hosts, or Namecheap, or any other centralized storage. We deploy, is working. We've built a dApp, yes, but the dApp we've built will be known as a hybrid dApp because it's not 100% decentralized. We've added the storage, or rather, we've added the hosting as on the AWS server, and that is centralized. But if we choose to use IPFS to store our data, then it is 100% decentralized. So IPFS is a distributed file system for storing and accessing data. So rather than storing our data in AWS or any other similar database, the IPFS system will distribute and store our data in a peer-to-peer network, which makes it easier for us to retrieve it when we need it. But like I said earlier, it can get expensive really fast. But if we want to build a complete dApp, from top to bottom on decentralized blockchain or not centralized system or servers, then we'll move over to IPFS or Swarm. IPFS also has an incentive layer known as Filecoin. This layer, this node, incentive nodes, forms a layer around the node that stores and receives the data. We can also use providers like Infura to a Pinata. Pinata usually provides, Pinata provides an easy to use service where you can pin your files to the IPFS and take the IPFS hash and store on your blockchain and retrieve similar like that. Swarm too is similar in that it is also a decentralized storage network. But there is one difference between Swarm and IPFS. Why Filecoin, which is a part of IPFS, is a separate system. Swarm incentive system is built and enforced through smart contracts for storing and receiving data. Okay, I feel like I'm not speaking plenty grammar. In summary, not in summary, I'll just try and break it down again. To store data, to handle storage on your DAB, you have two options. Store and host on centralized servers like AWS, and that will mean your DAB will not be a hybrid DAB. And you want to go fully decentralized from top to bottom, that is where IPFS and Swarm comes in. As you can see on the architecture on the screen, if we host our DAB on the code on AWS, as we normally do in any Web2 applications, what happens if AWS goes down? What happens if they censor our application due to one or two policies? It defeats the entire idea of a decentralized application, because the relation is about there is no one entity that controls the entire system. As AWS is, because of this and this, you're taking out your website, that defeats the whole thing. And so IPFS would definitely be the ideal for a top to bottom decentralized application. But now we're saying that hosting it on a decentralized application like IPFS can get expensive really fast because of the data and gas fees connected to that. So people usually not really host on IPFS. What we see most of the cases are hybrid dApps. OpenSea is a hybrid dApp. There are other hybrid dApps as well. There are other ones like Oxen is a hybrid dApp. Chainlink is also a hybrid dApp. Basta, Cardena, they're all hybrid dApps. There are also fully centralized applications as well. So this is actually, sorry, hold on. Any questions? Let me take questions while I switch my network. All right. Okay. So of course, that's a lot to take in, no doubt. But like I said, and I'm not very sure about that, we have 20 minutes to go. There, once you begin to practicalize this, write your own smart contract, host, interact, you definitely understand how this works in better sense. And of course, try hosting in IPFS. I know they're quite, because test nets may not entirely give much headache, but then just try and experiment as you can. That's the only way you actually get better. Building project, experiment, fail, and come again, then that's totally fine. Now, if you look at this architecture, it gives a more broader approach. And of course, going deep down can also be a lot confusing. And so querying data on the blockchain, that is where you have things like w3.js or atas.js, your libraries to query and listen to smart contract events. You can listen to specific events, simplify callbacks and function when event is fired. We have the graph. The graph works in some limitation. I mean, the what's it called now? Querying using Ether.js, or the common way of querying, has some limitations. For instance, what if you deploy a smart contract and realize that that there's an event that you omitted that you need to add that was not originally included? Smart contract, when deployed, cannot be edited. They're just there. They can't be edited. So what if you realize that, as a mistake and as an event omitted that you want to include? Unfortunately, you cannot redeploy a new smart contract. So you have to redeploy a new smart contract with that event and data. But using callbacks to handle various UI logics, would be a lot easier. No, it would be complex. That is where the graph comes in. The graph is an offsite indexing solution that makes it easier to query data on the Ethereum blockchain. What the graph does is to allow you to define which smart contract to index, which events and function calls to listen to, how to transform incoming events into entities that your front-end logic can consume. It uses the GraphQL as its query language, which many front engineers are familiar with. Some people actually love GraphQL to traditional REST APIs. So that can be a very better use case to index blockchain data. That is why the architecture looks like it, for those who want to include that into their dApps. Now, scalability issues can come with Ethereum as a raw blockchain itself, but layer 2 solutions like Polygon can help with scaling the blockchain as it increases. So once you definitely dive deeper into the development of this blockchain itself, blockchain dApps, blockchain applications dApps, yes, itself, then you can begin to understand these things on a more closer level as it executes, interacts, and do as well. Smart contracts are the core ingredients of a dApp. Smart contracts cannot be omitted when building a dApp. I may not be a very fantastic chef, but I know you can't cook egusi soup without egusi. You can't do egg without egg. So it doesn't make any sense. So we cannot build that without smart contracts. Those are the underlying, what's the word now? They are the core self-executing code that we can use to interface on the back end of our Ethereum chain and communicate that outward to the front end. And the whole architecture goes in circles and in circles. Is there any question? So I understand that it can be a lot to take in, yes. But I'm very certain that as you progress, it will definitely make a whole lot of sense. And smart contracts are very important. That is why we understand that building smart contracts can be a pain for different use cases. For front-end engineers in the Web3 space who may not have the experience or expertise or even the strength to go and learn Solidity, may be stranded or handicapped. Even those who are smart contract developers themselves may need a solution to fast track their building. And that is where Bunzz begins to come in and to accommodate blockchain developers across board to fasten and improve their solutions. And Bunzz has ready to make smart. Okay, that's a question. Long time coming. Okay.
Yeah, thank you very much. So I just want to be sure, like Ether.js and Web3 JS, are those like frameworks for communicating with the blockchain? Thank you very much.
Yeah. Yes, they are JavaScript libraries to communicate with the smart contracts deployed on the blockchain. You got that? All right, cool. Yeah. There are, you also have for Python, we have web3.py for Python. We can build or write smart contracts in different languages. We can write smart contracts in Python, we can write smart contracts in Java, but then they're not for Ethereum, no doubt. There are other blockchain platforms out there that can accommodate those blockchains with smart contracts. But for Ethereum itself, Solidity is the primary language that can write for that. Yeah. So Web3.js and Ether.js are JavaScript libraries to interact with smart contracts deployed on Ethereum blockchain. So Bonds has ready-made smart contract combination for different use cases, eliminating the blockage for most front-end developers who want to quickly build apps, and of course simplifying and improving the process for smart contract developers who want to fast track and build upon existing template models across different use cases, marketplaces, ICOs, token, DeFi. We also have NFTs, of course, being part of that. Different smart contracts, ARC721A, 1155D, and so many other new smart contracts coming around, basically for EVMs. EVMs, of course, Polygon, Avalanche, BSC, EVM itself, Ethereum itself, Asta, and so many others. We'll not go deep down into how this works, but in our next workshop, once you have already established a good understanding with the coding aspects of the whole program, we'll come back and look at how Bonds can fasten that particular track. But quickly, before we give rooms for more questions and wrap up and have some final words and reminders, we want to take a quick demo to see how we can deploy smart contracts to the front end in 5 minutes. We not do front end. The front end can be next time, but we just do deployment of smart contracts in 2-3 minutes, 5 minutes at most. So the first, of course, would be for us to head over to bonds.dev, which is the official website of Bonds, bonds.dev. Perhaps when we get into the implementation part in the workshop, the front end will be updated. We're yet to push out the final stage of the UI improvement. So quickly, we'll go to login. But before that, we have the Explorer. The Explorer tab here allows you to explore different smart contract templates that exists on Bonds. I'm sure you can't see anything yet because it's not network. Okay, let's hold down. It seems like it went from frying pan to fire on my switching networks. Just waiting a little bit. Just hold on. Oh, nice. Oh, am I still on the call? Okay. All right. All right. So to make sure I'm still on the call.
Oh, you're still on the call. Charles, can you hear us?
Yeah, I can hear. I thought so.
Okay, maybe this is glow effects, man.
Idris, what do you mean?
Yeah, so while he's trying to fix the whole thing, thank you all for joining once again. I think I'm sure he would be rounding up very soon. And so I want you also to take note of whatever he's doing right now, because he's literally just giving expo to sorry about that. Understanding the whole thing, and while we proceed with the other workshop, you just get along the whole process. So when it's time for you to build at least minimum of maybe a smart contract doing something and deploying for you to be able to participate in the hackathon, you already have like full insights, because at the end of the day, maybe you don't know, well, we also plan to announce to everyone and make it clear. Bunzz is the one sponsoring the hackathon, and we will literally be deploying or doing stuff on their platform. So you should just take notes, write whatsoever thing you want to write down. This video is recorded, we share with you when it's being uploaded, after uploading rather. And then the slides, hopefully we get it from our speakers to share with you if you want to follow up. And for others that are not probably on this call for one reason or the other, please, if you know anyone, just tell the person to check the video once it's ready, and they can just follow through the same thing. So we try as much as possible to make this a self-paced learning, in as much we are aware that this might be a lot of information for especially people that are new in the space. But we believe that the 7 days remaining in the week will be enough for you to do something on your own before the next workshop. All right, so I think our speaker is back. All right, thank you very much.
All right, thank you very much, Idris. Yes, we are almost to the end. Yes. So this is the Explorer page on the Bunzz platform, where you can quickly get a look at all the existing smart contract models or templates that you can use to quickly build your dApp or build upon the use case that you have. We have the payment splitter. We have the reflection token, escrow, smart contracts, best in wallet, smart contract, NFT maintain, simple marketplace NFTs, auction marketplace, and the rest of them. If you click on the what's happening? Yeah, if you click on the payment splitter, it gets to show you an overview of the payment splitter, how to use the payment splitter, how to payee, and breaks down the concept, model parameters. You get to okay information here. Function, get to see the write and read functions, receiver, the type descriptions, remove payee. So payment splitter, basically, you know how you can use case can be in a payroll system for an organization. Having a monthly payment or salary for every month. We have different wallet addresses for different employees, and as a single addresses that shares all the whole money and the tokens to them. At the end of a particular time or date set, it transfers the money to everybody, and we can track down and see, oh, we have to share this money and it's there. What kind of use case can be that? Or even has to be a use case of agreement. I'm taking 50, 60, and it splits the payment across two. So there are different use cases depending on what you want to use. You can look at the function and see if any of this makes sense to you. And then there's a code. To look at the code for interfaces and the smart contract splinter itself, you can look at the Solidity code and get to confirm if that's what you need to use or not. You can customize the code in your ID, but this is not yet available. Maybe when the hackathon comes, it will be available. For now, it's not. Now, let's deploy the payment splinter smart contract. You can see the deploy function here. There's a different route to follow, but we'll look at that in the next conversation workshop that we have. I'm currently connected to BSC testnets. As a deploy, as a create dApp, so I'll just say payment splinter as the name of the dApp. Oh, sorry. Yeah. Go back. This is actually the first screen that appeared. And nests. So we have different. Is that a question? Okay, maybe not. We have. Okay, yeah. So there are different test nets and different main nets for different blockchain platforms. Ethereum has a mainnet testnet. The Golang is definitely being deprecated, so that will be out soon. We have the BSC mainnet testnets, Moonbase, Polygon, Condensers. We have quite a lot, but if the seller is not here, and if there are anyone that is not here that you like to use, that is where the custom chain comes in. Putting the ID and set. So I'm setting the current chain. I have BSC testnet 97 is the chain ID. And I'm moving, so I already have the payment splinter added here, so that's fine. And there's so many other ones here, but that's not business. That's next. Deploy. So creating, we have to sign transaction fee 3 times. So that is 3 times the first one. screen has stopped sharing. Are we done? Yeah. Okay. Yeah. So we have it's done. So back to the so it's deployed on the BSC testnet. And if you are so like I said, once you definitely are familiar with the code in your previous in the next classes, eta.js, you know that you definitely need to copy the smart contracts and the ABI to definitely interact with your smart contract deployed on the BSC testnet, any other testnet or mainnet or network that you have in mind. You can verify these contracts, and you can look at the functions. So one of the key thing about Bunzz is that you can definitely create a token, resident token, and interact with it using the GUI without going to the code. You can deploy my own token and add, initial coins, no, initial token rather, initial tokens, and mint it and begin to share and deploy all these things. But if, of course, developers have more use cases for that, and so hence the ABI and the smart contract comes in play. So we'll look into this in more details in the next workshop, where we're going to be building dApps using the the Bunzz platform across different segments. There are boilerplates that are existing dApps that have been built to help you kickstart quickly across payment splitters, across minting, NFT minting platform, marketplaces, and the rest of them. There's a documentation page, of course. And we used to have a client SDK. The SDK was the first value proposition we have for developers. We wanted Web2 developers to begin to build dApps without having to go learn to EDC. And so we had to provide them with SDK, which means that they can build dApps the way they usually build Web2 applications in SDK and JavaScript. But this SDK has been deprecated and will probably last until a few months. And so we recommend using eta.js to interact with the smart contract using what we already deployed using the ABI and the smart contract address. So this is, in summary, a quick demo. We'll go into more details, especially the monitoring, the standard models, and most of them, analytics, and repository, and all those other stuff. So look into that when next we meet. Is there any questions? Yeah, final. What's the word now? I said there has to be a final. Yeah, go ahead. Questions.
So my question is like, so Bonds is like a larger framework for accomplishing how will I put it? Like for building like DApp applications. That's what Bonds is like for.
Is Bonds a framework? No, it's not a framework. Bonds is not a framework. It's a smart contract hub. That's the safest way to put it. A smart contract hub. You know how Docker Hub does, right? Not just Docker Hub. Let's assume we have, GitHub, right? So GitHub has so many open source, what's the word now, applications you can use, and quickly look at that and use and do all those things. In similar case, Bunzz is a smart contract hub, amongst other things, but the key is smart contract hub. There are different smart contracts for different use cases, and quickly build dApps you need to build using the use case that you find. You can use that and combine. You can even bring in your own smart contracts you deploy to connect and easily deploy and interact with. Next conversation will give us a more broader sense, but it's not a framework. It's best to say it is a blockchain as a Web3, no, a dApp building platform. Yeah, a smart contract hub. That's the best way to say that. Yeah. Was that question answered, Smith? Is that you that asked the question?
Okay.
Yeah, Smith.
Oh, okay. My question is like, okay, so bots is just like, it has reusable smart contract codes that any developer can use, right?
Okay, I'm not sure I got you clearly, but what I got is Bonds is a reusable smart contract. I'm sorry, I think I get that.
I think he was asking the same question I was asking, the feature, like what
Yeah,
was
yeah.
going.
Yeah, so Charles, I think from what you said, he's saying that so Bonds is like a platform for reusable, smart contracts and
Oh,
all of
okay.
that.
Yeah,
Yeah, it's
yeah, yeah.
just somewhat similar to what Ozzy asked. But I believe that should answer his question.
Yeah. Thank you. Yeah, that's definitely Smith. Yeah, that's the yeah. It's actually a reusable smart contract. That's correct. Yes, it's a smart contract. And so I mean, there are different roadmaps to this. At a point, given the direction, we could begin to reward contributors with bonds tokens based on the usage of their smart contract. But it's still in development, but entirely it's just to fasten the development space for the for blockchain developers. Yeah, that's the answer. Smith. Okay, yeah, go ahead, Tiro.
Yeah, so does Bunzz also like have RPCs and all of this, or how does that work?
No. Yeah, no RPCs. It's just a smart contract. Now, when you deploy the smart contract, of course, there are other things that need to be set up. Mostly, the SDK had most of those features, but now it's no longer there are being supported. So right now, once you deploy a smart contract to any of your blockchain network of choice, as an ABI and a smart contract to use on your front end, and you have to set up the other things that have to set up. So of course, we're improving on the product to include other other components that can make it easier. But for smart contract deployment, that's the key value. I'm trying to make it seamless. But for now, there's no RPC support any other thing like I know what you're trying to say, but no, for now that's not existing. All right, great. Okay, okay, yeah. So I think that's pretty much it. We'll definitely dive down into the bonds and the whole ecosystem of bonds in our next conversation, right? Okay, just hold on. Just one more slide. Sorry, yeah. Okay, so learn by building. Basically, I think that's my own personal as action for the entire blockchain space. In every conference I attend, every class I attend with blockchain developers, I always encourage everyone to build solutions. We've all talked about theory of blockchain so much, security, transparency, immutable. We've talked about those things. Can we see it happen? Like, can we see the real application of this thing? Let's see solutions by that. I'm really optimistic that the Web3 Africa Bootcamp and the program will definitely bring out the developers who are not just talking about these things, but are building and talking at the same time, right? So it's more like building. We're trying to build stuff, trying to build, and trying to see how we can leverage. The last it was yesterday. I think that was yesterday. There are so many use cases for bonds, receive solutions where bonds was used to build a dApp that stores patents on the blockchain. You know how you do patent ideas, patent day. Someone built a patent that stores patents. Others built an ICO platform. So we're happy to see these solutions come out, and I'm very optimistic and can't wait to see what happens at the end of the hackathon or the bootcamp generally by having the developers who can build as well as tell the stories about blockchain. So let's try and move around from theory and go into implementation and showcase truly that the blockchain tech is the sweetest thing to happen to the web space. And that'll be all from me. Thank you very much. So trust at bonds.dev is my email. But Twitter is fine. I'm not a Twitter person, but I try to show up once. But as a Discord community for bonds, I'm always there 247. I will share that at the second workshop. But yeah, that's all from me. Thank you very much. Any questions? If not, I think I'm done. And Neola can begin.
Thank you so much, Trust. I really enjoyed the entire session, and I'm sure everybody else did as well. So, do you guys have any questions for Trust, please? Anybody? Okay, Trust, do you have any question that you want to ask everybody? Anybody? Like any question to know that okay, they really followed you during the training.
All right. Yeah. So the question. Yeah. So the question I want to ask is, at the front end. Oh no, the difference. Basically, on a what's what now? On a basic level, what's the difference?
Yeah, sorry. Anila, please can you answer that? It's
All right.
echoing somewhere.
Okay, cool. Yeah, so the question would be, two questions. First question is, what's the basic difference between a Web3 application and a Web2 application? in terms of architecture, right? Difference between I see it's good, Kenny. I know Ovia has talked. Yeah, it's good. No, sorry, not Kenny, hold on. Ayodeji, yes, Ayodeji.
Yes, in my opinion, Web3 architecture is more complex, more robust than Web2 architecture, so to say.
Yeah, thank you very much. Smith, yeah, go.
The difference between Web3 application and Web2 application is that Web3 application is decentralized, and while Web2 application is not decentralized. In the sense that the back end structure is different from Web3 for Web3 applications, while the back end structure for Web2 application it has one single server kind of.
All right, thanks for sharing. Thanks for sharing. You listen. So lastly, let's give Kenny.
Yeah. So to add to the differences between Web3 and Web2 technologies, the difference between Web3 and Web2 technologies is in the communication, the link between the front end and the back end, which is the Ethereum virtual machine. There's a provider between the front end and the back end, which is a layer that is absent in Web2 technologies. Thank you very much.
Yeah, thank you very much, Kenny. Second question would be, what is a hybrid app? Yeah, let's give to Ovi.
So a hybrid app, well, um, hybrid apps essentially they combine Web two, like some Web two like basics to Web three. In this sense, now what I mean by that, instead of hosting on like on an IPFS or Swarm, like they decide to host on cloud servers, centralized like cloud servers like AWS, Azure, or whatsoever.
Yeah,
And like the reason why they do this is because of cost effectiveness.
thank you very much. Kenny, any contribution?
Yeah. I agree with Ov. Yeah, an hybrid DApp is an DApp application that uses both Web3 and Web2 technologies, just like the AWS services. Maybe instead of using the IPFS, you have your data stored on some AWS S3 service like that. So, and just like you said, it's to reduce cost, because when you're doing right actions on Web3, you need to pay for gas, so it gets expensive while doing that. So these are one of the reasons why you can do an hybrid DApp. Thank you very much.
Yeah, thank you very much. One last question. What is the pitfall of using AWS, like you said, hybrid apps, hosting the data or storage on AWS, GCP, or any other centralized server? What's the pitfall that defeats the entire blockchain idea? All right, Ovi. Oh, sorry. Ovi. Intiro.
Yeah, it defeats the whole purpose of decentralization. The things that come with centralized services is it could be censored, it could be inhibited in any way if what's his face, Jeff Bezos decides that he wants your website down. You have no options, but it's difficult to censor things that are on decentralized networks.
Yeah, Ovi. Thank you very much, Intiro. Fantastic. Ovi, any other remarks or something similar addition?
Yeah, I just wanted to speak on regulation too. Like that's the problem with centralization.
All right, thank you very much, everyone. I appreciate the class, enjoy the class. So, really, apart from the coding aspects, it's also good for us to familiarize ourselves with the other architectural aspects of the blockchain and understand how that works in deeper sense. So, thank you, everyone. Yeah, in your life, you can proceed.
Yeah, thank you
Yeah,
so
thank you
much.
so much. All right. Thank you,
Um,
everybody. Okay.
sorry,
Go on now.
just quick one. Yeah. So, thank you so much. Sorry to cut you in your lap. I just wanted to quickly add one thing. First off, thank you once again, Trust, for that wonderful presentation. Another thing is to all that joined, all the people that joined today. Um, I just wanted to put this out there that just like Charles mentioned about you need to learn by building, right? And so far, we've gone through the process of, explaining the fundamentals, like why do we need Web3 itself, and now you've learned about like Web2 and Web3 and all of those things, right? So like the differences, how you can host, and they even give you like you got like hints, right, on how to do things on bonds, and which will be very useful for you when you want to submit an entry for the hackathon and all of that. Yeah, so um, what I wanted to actually talk about is this session would likely be happening on Thursdays. So we will need to check in with the calendar. So it might probably not happen every Thursdays, but we'll communicate the next one that will happen, like the exact date and time, which will literally be on Thursday, but might not be next Thursday, right? So I want everyone to understand the difference between like the workshop and the webinar. So the webinar basically helps support whatever thing we've learned during the workshop, and the workshop date doesn't change. It remains on Mondays by 5 p.m. So the next class here would be Monday, and we'll be having CAS, should the case you still remember that name, our very first auto facilitator in that session on Monday. And then the next Thursday, which will be facilitated by Bunzz, we'll definitely communicate what Thursday that will be, probably next week or the um, the one after next week. So we are already 2 weeks into the program. We have 4 weeks to go. Please just buckle up. Things will get practical like from the next class, and this is just to equip you with the right skill set for you to utilize during the hackathon and even beyond the hackathon. Like the truth is that we want to be a smart contract developer. We want to be a blockchain developer, and you don't want people to tell you, "Hey, come and build an NFT connection for me," and you are telling the person that you don't do practical, you only understand theoretical aspect of blockchain, right? So that's a big mess. So another one is you should also understand that this whole program is being monitored, and there will be a certification after the whole program. I'm saying this for the first time, right? But that's the truth. Just to reward everyone that participates and also those that shows commitment and contribution, despite the fact that we know that there's an hackathon at the end of the program, but still we want to like appreciate everyone that puts in the effort to learn and build something throughout this program. Thank you very much. I pass the mic to Eniola for her to round up so that we can call it a day.
Thank you so much, Idris. Thank you once again, Trust. So that's basically everything I want to say. So see you on Monday. Monday, okay. Similar, what you have the mic?
Yeah, thank you very much. I'm sorry I have to start coming up
All right.
every now and then. A quick one. I think I'm feeling so isolated. So I want to suggest if those of us in the same life stage
Sorry,
of life.
Eniola, please can you mute your mic? Okay,
Okay,
yeah, please go again.
this goes to my colleagues. If we can just bond and probably we miss something in class, we can quickly recap in a WhatsApp group or something. I want to suggest that I've been feeling so isolated since I started this program. So I don't know if we can just use that opportunity to meet up. And I think it can aid our learning as well. I can just bump onto someone at any time of the day to probably clear me on something.
Well, it does dependent on everybody's choice, but the Discord is there